Hello everyone, today we're introducing the deployment of Qwen3 VL on rockship RK3588. This is the most powerful visual language model in the Qwen series released so far this year. Looking at this diagram, Qwen3 VL's smallest released version is 2B. This 2B model has 2 billion parameters. The largest version has 32 billion parameters. Of course, it may exceed 32 billion at maximum. It could be even larger. We see the smallest version is 2B. This is the model we deployed on the RK3588. So how do we deploy 2 billion parameters on an RK3588 with only 6 TOPS of computational power? That's exactly what we'll cover in this session. Before diving into the deployment details, let's first demonstrate how it performs. Specifically, we'll show Qwen3 VL running on the RK3588. We simply run this command to activate the pre-deployed Qwen3 VL model. As you can see, it's now operational. We've loaded an image into it. Let's open this image for everyone to see. Alright, take a look at this picture. Now we'll ask this large model, what is in this image? Let's observe how it responds. Notice how it first conducts its own analysis, then identifies the primary elements in the scene: astronaut, lunar surface, Earth, beer bottle, other objects. Plus a cooler. It recognized that too. Overall, this is a very interesting image. As you can see, its response is quite accurate. Qwen3 VL can process not only image and video data, but also natural language data. Now let's ask it a few questions. See how it responds. First, we ask, who are you? It's an AI assistant with no physical form. What can you do for me? Let's ask another question. Generate a description of the RK3588 for me. Pay attention to whether this information contains errors: rockship, high performance, ARM architecture. This is correct. Built-in NPU, multi-core CPU, high-performance GPU. Some may not know this, but the rockship RK3588 also has a GPU. Now let's ask it another question. Generate an introduction to calculus. Notice how quickly it generates, virtually no delay. Now let's walk through deploying the Qwen3 VL vision language model on rockship RK3588. The process involves these steps. Step 1. Prepare the environment. But first, you need hardware. Specifically, a device with rockship RK3588. I'm using the OrangePi 5 Ultra here. Then I can press Ctrl+Z to exit. After booting your RK3588 and accessing its interface, whether via a graphical interface, or SSH like I'm using now. The first step is to set up the required environment. This environment consists of two components. First, Rockchip's RKLLM, which is Rockchip's dedicated SDK for large models. Second, RKNN. This is an SDK specifically developed for its NPU. The second one, RKNN Toolkit 2, can be installed directly using PIP. If you encounter an error indicating RKNN is missing, you can resolve this issue with this command line. To install the package. The RKLLM toolkit cannot be installed via PIP. There are two ways to obtain it. The first method is to clone it from its repository or directly download the package. Alternatively, you can click the link provided here. Of course, GitHub may be slow to access if you're in a domestic environment. Another method is to click the link here. This one. Then enter RKLLM and click OK. You'll find the SDK zip file there. Select the latest version 1.2.3, then download it directly. OK, this is the first step of deployment, installing dependencies on RK3588. The second step is acquiring the model. There are two ways to obtain the model. Specifically the Qwen3 VL model we're deploying today. The first method is via Hugging Face. Qwen3 has open-sourced most Qwen3 VL models on GitHub. He also open-sourced the domestic model scope platform known as ModelScope. It's called the ModelScope. You can download it there as well. After downloading, we recommend testing it using the sample provided below. To check if your downloaded model is complete. Now, as you can see here, Qwen3 VL comes in several versions, 2B, 4B, 8B, and 32B. These versions represent the number of parameters they contain. The 2B version is the smallest, with 2 billion parameters. The 32B version is the largest, with 32 billion parameters. For this session, we're using the 2B version. If interested, you can experiment with other parameter sizes. Of course, there may be more options available. You can also search for Qwen3 VL on the ModelScope. You'll find numerous models here, including fine-tuned versions and quantized variants. For this guide, we'll select Qwen3 VL 2B, though you can experiment with other versions using the same method. OK, when downloading from Hugging Face, network issues may cause problems. I recommend using ModelScope instead. That's how I downloaded this model. ModelScope offers two download methods. The first is installing the package and using its command for one-click download. The second method is downloading via the SDK. Another option is using Git for download, which is also quite fast. After downloading, the model will be saved in a directory. Navigate to this path for easy access later. This covers the model download process. Next, proceed to the following step. Please refer to this diagram. This illustrates our overall deployment approach on Rockchip RK3588. It's a framework diagram for RKLLM, Rockchip Speech Model SDK. First, download the model, the native model. Then deploy it using RKLLM. After deployment, use its interfaces for inference acceleration. Once these steps are complete, you can achieve the effect we demonstrated earlier. In an offline environment, on an edge device. Like your RK3588, you can locally invoke that large model. Using Qwen3, the most powerful visual language model in the Tongyi Qwen3 series. Alright, next we still download the original model. Then convert it to ONNX, followed by conversion to RKNN. Note that after RKNN conversion, it must be further converted to RKLLM. We'll walk you through each step. If your RK3588 development board has decent performance, you can perform this model conversion directly on the RK3588. Of course, you can also do it like I did. On a Windows PC or other x86 computer. One important note during conversion. You need to install transformers. Note, we recommend sticking with version 4.57.0. Additionally, you'll need a specific torch version. Avoid using torch versions that are too high or too low. I initially installed a too high torch version, which caused this error. So I later switched to version 2.4, ran the conversion code again, and finally succeeded. Note that SDK recommends converting to 224 by 224. Pay attention to this conversion code. Export_vision. This is its SDK. There are two ways to obtain this SDK. First, you can directly clone this repository. Second, you can click the link provided here to download its compressed package. Then, this conversion code is located here in the export section. It's export_vision. Notice it requires importing torch and transformer. These two are absolutely essential. If you're not using RK3588, you can copy this code to your Windows computer like I did. After setting up your environment, you can load it directly here. Download the model, then start the conversion. One more important reminder, you must use a virtual environment. You can use Conda like I did, or Python's built-in virtual environment. However, regardless of the situation, I strongly recommend using a virtual environment. Because if you don't use a virtual environment, it has an extremely large number of package dependencies. And these dependencies will also cause you to encounter a lot of errors. You can see here the issues I encountered during the conversion process on my Windows computer. It started at 2.9.1, but this version was too high, causing it to throw a bunch of errors here. Then the model conversion failed. Here, I switched it to 2.4. And it finally converted successfully. After the conversion succeeded, it essentially ran on my Windows computer. This step can be completed, but you absolutely must use a local environment. And this local environment should ideally be newly created. Don't share it with other environments. Here's a reminder. First, create a new environment. Second, you don't necessarily have to convert on an RK3588. You can also do it on your own computer, even a Windows machine. After successful conversion, here's a small suggestion: it's best to use a virtual environment. After conversion succeeds, I used Netron, this visualization tool, to visualize the model. Let me demonstrate this again for everyone. After downloading, it saves here. Loading takes a bit of time. One more reminder, the parameters are also crucial. Specifically, Qwen3 VL, currently, RK3588's RKLLM, and SDK support numerous large models. Qwen3 VL is just one of them. As you can see here, it also supports Mini CPM, Qwen2_5_VL, Qwen3 VL, SmallVM VL, and Vilo 5 VL. It supports DeepSeek OCR. Yes, it supports many. You must confirm Qwen3 VL. After loading it here, we took 2 screenshots to show you. This model is still very large. After conversion, it's a full 3 GB. Once converted, the next step is to convert it to RKNN format for RK3588. Those who followed our previous content should already be familiar with this. If you're deploying to Rockchip RK3588, you absolutely must convert it to RKNN format. Otherwise, you won't be able to leverage Rockchip's NPU for model inference acceleration. Notice I first placed the converted model here and imported it onto the RK3588 computer before initiating the model conversion. Note, I created a new training environment again. If you skip creating a new environment, you'll encounter numerous strange errors. After setting up the training environment, it isolates other packages and software, creating a fresh environment. With this new environment, you only need to install the dependency and use this command to convert ONNX to RKNN. Here's a screenshot after successful conversion. The code is also in this export directory. You'll see it's this export_vision_RKNN. Note, you still need to specify the model name here. Make sure you get your model name correct and don't mistype it. After finding RKNN, the next crucial step is RKLLM. This is essential for acceleration. Then, for RKLLM, you can obtain its SDK here. As we mentioned earlier, you can either download it directly via Git, or download the compressed package right here. If you prefer not to convert it yourself, you can directly download the pre-converted model provided by Rockchip. If you want to handle it manually, you can use the following command. This process still occurs here. It requires quantization first, followed by differentiation and exporting. Then, convert the RKNN model into an RKLLM format. You can try this approach, but for final use, you'll need to load 2 models. One is your RKNN, and the other is RKLLM. Alright, at this point, the model conversion is fully complete. The next step is tackling deployment. Regarding deployment, the latest version of RKLLM does not offer a Python interface. It only provides a C++ interface. This interface is quite straightforward to implement, but you may encounter some issues. Let me explain. First, where is this code located? Everyone, pay attention to RKNN, whether you're using Git, downloading, or working with compressed packages. Note that after you enter the directory, the CPP files are located in the deploy folder within the model demo. You can see them here. Logically, you'd expect to run build Linux directly, but it will throw an error. It can't find a C++ compiler. After troubleshooting, I discovered the script itself is flawed. Specifically this part. It simply doesn't exist on my RK3588 board. So I abandoned the script entirely and compiled manually step by step. At this stage, I made some adjustments. As you can see, the modified paths are documented here. I directly used this cmake command. Then compilation commenced. Once located, proceed normally with the cmake control file, then run make, followed by make install. After completion, here's a screenshot of the final result. Finally, we arrive at this point, which is the image we showed at the beginning. Do you all remember this image? And this response? And this text-based reasoning? Now let's take another look. At this point, our introduction for today is coming to a close. Finally, if you have any questions, feel free to give us feedback. You can also try deploying Qwen3 VL on Rockchip's RK3588 or other chips in their series. Give it a try. Alright, that's it. Our introduction and sharing are now finished. Thank you all very much for watching.